Welcome to LeGrand Industries, an industry lead in manufacturing solutions. Today we'll be investigating how we use different methods of control systems in manufacturing. Specifically, we will be looking at one example of this tank system with a few variations in control methods. First, we will be discussing how the control relays work. Control relays are electromagnetic switches that, when power is applied to the coil, turns on the electromagnet, pulling a conductive fork from one side of the contacts to the other, turning one internal circuit from open to closed and another one from closed to open. In the pump example, only one side of the common is used to turn the pump on and off, but a second function of off and on could be wired in. Now let's look at what's happening inside the relay. Output 2 is a normally closed system, so when the relay is not powered, power can flow through output 2. When the relay is energized, the contacts switch over and power flows through output 1. Next, let's look at a few different examples of ladder logic systems. The first is the most simple. When the start button is pressed, the normally open switch is compressed, completing the circuit, powering the control relay, which closes the contact, and the relay goes from open to closed. Additionally, hitting the stop button will open the contact briefly, de-energizing the coil and turning off the system. Another iteration of this system is one with a high float switch, which is normally closed until the fluid level reaches it and flips it open, de-energizing the coil, which stops the pump. The start and stop push buttons act as seen in the first example. The next example is one with two float switches, one normally closed high-level switch and one normally open low-level switch. This scenario would be for when the pump can be left unattended with the pump on or off. In this example, the start and stop buttons function as normal. Additionally, if the fluid level were to drop below the low-level float switch, it would go from open to closed, completing the circuit and turning the pump back on. Here are all the components that make up the last scenario. On the left we have the mixing tank with a high-level float switch and a low-level float switch. On the right is the supply tank with the low-level switch, and then in the middle is the relay control cabinet and the pump. The final scenario is as follows. When enabled, the pump will turn on automatically when the liquid level drops below the low-level switch in the processing tank. The pump will remain running until the liquid level goes above the high-level switch in the processing tank, or the operator presses the stop button. To prevent damage to the pump, if the level drops below the low-level switch placed at the bottom of the supply tank, the pump will shut off. Now let's look at this in an actual scenario. When the liquid level drops below the low-level switch in the mixing tank, the relay will switch and the pump will turn on. If the liquid level reaches the high float switch in the mixing tank, or if the operator presses the stop button, the pump will turn off. If the liquid level reaches the low-level switch in the supply tank, the pump will also shut off. Thank you for watching, and I hope you learned something.